Aloha! Greetings to you all for the new year. It's been gorgeous sunny weather here ever since the new year turned. The week of Christmas and right around there, it was dismal. We had a lot of rain, a lot of clouds, and my solar system on the roof was barely making ends meet for about that week around Christmas. It was enough, but barely. So considering that is normally a very cloudy, dismal time of the year when the days are really short, and we made it, that would indicate that the system was designed properly for this environment here. And currently we're producing electricity hand over fist. Ever since New Year's we went into the sun, and it's just been gorgeous here. The system is operating peak efficiency. I'm overjoyed with it. Now, it took us several months to get this system tweaked. It was not doing what we needed it to do initially. Now, the basic idea of using solar collectors on a roof to charge a battery, to power a house, that's old hat stuff already. We've been doing that for decades. There are some new things involved in it, but it's pretty much proven technology and there's no issues. But when I threw the monkey wrench into the works with Provision Solar as the contractor we used, I wanted to be able to use the sun to power my electric car. And this is relatively new technology. To begin with, electric cars are fairly new for us anyway. Devices that will take the sun and charge electric cars and is, again, even newer. I understand that there are only 4 of these devices that have been installed by Provision here on this island. There's a few more on Maui. So this is really cutting-edge technology, and we had all kinds of problems with it. Which are now, though, finally reconciled. I am delighted with the way this has come out. So let's go take a look at some more of it. Here you will see our electric car, the Chevy Bolt. Right down here, this little gizmo is a plug-in from our panels on the roof to charge this electric car. Currently, the car is charging. So, right here is the gizmo that we use to charge this electric car. This device is made by Solar Edge. I don't know how many other people there are out there working on solar car chargers. They're definitely one of the few. This again is brand new technology, and so we had all kinds of little issues that came up with it when it was put in. This right here is the inverter by Solar Edge. This is what controls where the juice is going and regulates it. The way this is designed, and this took us a while to figure out, and this includes the contractors who put it in for me, because no one really knew that much about these. They're too new. So once we got it in there and we realized that to make this work, once they had to add a device that split the charger from the solar panels on the roof and the grid. I don't know what that was called, but it wasn't in the system initially. Then there were some software updates that had to be made and blah, blah, blah. Eventually, we ended up with a system that if I plug this into my car and leave my car plugged in any time that I'm not driving, this unit will decide when my battery bank is full and I am not using extra power in the house, and so any power that would have gone up the wire to the grid, which for us would have really been a waste. Helco only gives us credit at 33 1/3 cents on a dollar for what they charge me per kilowatt, and it terminates at the end of the year anyway. If I don't use these credits up, they go zero. So the whole thing is definitely written in favor of Helco, the energy corporation here. So it's not desirable for me to allow the power I create to go up their wire anyway. Some of it does. Main reason I keep the wire in place is because if I happen to need that extra power, I have it. For me, that's a real plus. And so I've stayed on the wire. I can take the system off of the wire. We did the other day. I was, we're working around the house and getting things ready for the holidays, and I just happened to check the app on my batteries, the Tesla Powerwall, and it pops right up with this message that says, "Oh, you have a power failure." I'm going, "Oh man!" I went out, and sure enough, the grid had been down for hours. I know my neighbors asked me, "How'd you do with the power failure the other day?" I didn't know there was a power failure. That's one reason I put this system in, because we will typically get power failures once to twice a month around here. Everything is above ground. All the wires are above the ground here in Hawaii. They're not buried, and so, every tree limb that breaks hits a wire. Every drunk who hits a telephone pole knocks the service out. And so it's going out all the time. I was really tired of it. Well, there it went out, and I never even knew. It had been out for hours. Well, when it started to come back on, it surged. It was going on, off, on, off, on, off, on, off. And it was driving my system nuts. And so what I did was I just went out and I just shut the wire off. And so we ran the rest of the day just strictly here on our own system. This system will run independently on its own without the wire quite well. The wire is just there for backup, and if I'm over-generating, which today we will over-generate. So, as I'm saying, we get this extra power. It's not being used, and so this electric car is a real plus. Because this thing right here, now that they finally got it dialed in and the program's right, it knows what is extra power, and it will only allow that much of it to go over here to my car. And so we can still run the clothes dryers, we can cook with this stove, everything else is perfectly normal, run the lights, and it's only when I have additional power that would have gone up the grid that it sends it over here to my car. And as long as I keep the car plugged in all the time, that means, several times a day, it'll be going on and off, on and off, on and off, sending current into the car. We didn't quite understand this about the system when we first put it in. I did not realize you were supposed to leave it basically plugged in whenever you weren't driving. Now that I got that down, we're really getting to like it. It's super. Now I can override it. If I want to just go straight from the grid, go full tilt, which is, I think, a charging rate at about 7.5 kilowatts is what it will pull when we're at the total max charge. It will. I can override it, and I can tell it, no, ignore all the other stuff I told you before, and just pull it right down from the wire. So in the case that I have to do that, this will do it. But in the meantime, on the program that it has, it's just going to eke over extra power trickling the car. Now on a day like today, it's really going to pile it in there. I'm not doing any laundry, and I had no major cooking events to go on. We use electric for drying the laundry. I use electric for the stove. And so most of the extra current today is all going to go into the car. Car will be full by the middle of the afternoon. We'll probably end up exporting juice to the grid again. Now that we have it dialed in and we understand how it was made to work, I don't think any of us knew that we were supposed to leave this car plugged in and that the thing would automatically cycle on its own. Yeah, not even the contractors knew that initially. So I am overjoyed now that we've got it straightened out. So let's show you the other part here of the system. Here we are at the closet in my carport, and in front of you, you will see what's called a Tesla Powerwall. This is probably one of the best devices on the market today for home storage of electricity when you have photovoltaic systems. It is about 4 inches thick, about maybe 4 feet high, and a little short of 3 feet wide. That puppy right there will power this entire house. That battery will go running this house on a light load for probably almost 2 days with no additional charge into the battery. On a heavy load, it definitely takes us from day to day. There's nothing to it. And it has the most extraordinary app that controls it. It's very high tech. I'll show it to you in a few minutes. Because of space considerations on my roof, we have half of our panels on the other side of the building. So on the southeastern portion of the roof, I've got one group on this side of the roof, which is pointing a little bit more towards the southwest slightly. We have another group. It actually works out pretty well because I get a really direct big charge first thing in the morning, and then as the sun turns later in the day, these get hit directly, and so they really carry a lot of juice in for us. If they were all on one wall or the other, they probably wouldn't be quite as effective as having split them. It had to be done for us because we just didn't have enough room up there on the roof to be able to put all the panels in one place. So they've been put in two. These are American-made SunPower panels. They have copper backings on them as opposed to the aluminum backings that you find on cheaper panels made in China. They're 20 to 25% more efficient than the aluminum backing panels. And so currently these are about the best and the hottest panels that you can find on the market. They are also, though, the most expensive. I don't figure to be on this planet long enough that I will have to worry about them wearing out and replace them. That will probably be my son's problem. And so I figure I only spend the money one time. So it really don't matter. This device is one of the things that had to get installed to be able to get the car charger to do what I wanted it to do, which was I wanted it operating so that it could separate itself completely from the grid and run only off additional solar energy that was coming in. This device here has the ability to separate those panels from the grid, and it had to be added. It was part of the problem we had. Without it, what would happen is I was pulling more energy from the grid to charge the car than I was pulling from the roof. And so this is required. Here you see a whole bunch of stuff that are basically just switching boxes for, this is the device for the generation panels on the roof. This is the one for the Tesla over here. Over here is a special power meter that we use that will tell me exactly how much juice I did pull down and how much juice I put back up. We happen to have two of those. There's the other one over there, is the one that Helco reads. Why they use this one, I'm not sure. They're identical. But that over there is Helco. And if I come on over here and I flip that breaker, I turn off the grid. And inside, almost nothing happens. It just switches over automatically. So power failures have almost no effect on us. Plus, the Tesla is so sophisticated that the other day I woke up and first thing in the morning my Tesla Powerwall said it had 100% charge. And I went, what? That's not really possible. Ordinarily, we'll usually burn her down to about 65%, 70% overnight. That a little bit of juice that we're using in the house in the evenings, you know, and watching TV or whatever, that it will lower the Tesla. Even if it was full in the middle of the afternoon, we get up in the morning and have a little over 60% as normal. But I had a full Tesla, and I'm going, huh? What happened? Well, there's a message there that says you have storms predicted. And so Tesla responds to weather predictions. There were some heavy winds that came through. They did create power failures here. And because the Tesla was setting up for a potential power failure, it automatically overnight connected to the grid on me, filled that wall rather than depleting it, to make sure if the lines went down the next day that I wasn't going to run out of juice. Now, this is all automated. It's pretty amazing, actually, the way it does this stuff. You know, it will let me know about grid failures. It will tell me how many of them I've had, and so on and so forth. But I didn't realize it was paying attention to the National Weather Service and actually making adjustments on its own on my behalf, which was pretty cool. because as it played out, if they hadn't done that, I may very well have exhausted my battery. It may have happened. I see that little light flashing there in the middle of the dashboard. That is telling me that we have excess power and that it's running into the car battery at the moment. There's also a corresponding flash over there on our charger. See a little blue one. It lets me know that is what is happening, so that we're feeding. I'm not a big one for apps and smartphones and stuff, but this system in the house that we have, both the Solar Edge and the Tesla, these systems operate on apps that will run either on Apple applications or they'll run on Android. Okay, so if you get a smartphone or you get a tablet, here I have a Samsung Galaxy, and on here you'll see I have the app up for Solar Edge. Now those are the guys that are doing the inversion, that is the conversion between DC to AC. They are also doing my car charger. And you'll see on top there's a picture of my house. It's got the panels up there on the roof. The temperature currently is up in the corner. And then you've got 3 little blocks below. One of them indicates the amount of power that's coming down from those panels. The other one indicates that my car is plugged in and charging. And the third one there indicates the grid, which means is power going to the grid? Well, let me look here. No. There's no arrow going to the grid, so we are keeping all power inside the house. The panels currently apparently are generating 4 1200 kilowatts that aren't being used inside the house. Everything else, 4 1200 is going into the automobile. Tap the automobile icon and I come up with this. Now if I tap it one more time, there we go. You'll see a screen right here that shows the car being charged, tells how much is going into it. It also has a blue button that says full power. And so right now I'm only getting about 4 kilowatts off the roof that's extra that's going into the car. Now if I hit the full power button, we're going to jump up to 7 something kilowatts. It's going to almost double, and it will also increase the speed of charging time by about double. Right now, since we're eking at only about half, it's going to take twice as long to charge the car up, but that's not an issue. That's why we keep it plugged in whenever we're not driving it. It fills. A little prettier, and I think I like it a little more too, is the Tesla app. This right here is Tesla app. There we go. There's a picture of my Powerwall battery, and it says 100%. So that's why the car is charging. We have no more room in the battery to store, and so currently whatever we're not using here in the house would go back up the wire to Helco. But it's going into the car. And then if I tap the power flow here, you'll see that we have 1/10. There's 1/10 of a kilowatt. That's running from the roof and running the house. So that's pretty much taking care of the LEDs, all the little vampires in there, and I don't know, maybe Ellen's got a light turned on somewhere. We're not using much power at the moment. In other words, that could be the radio, maybe, impossible. So then, if we go ahead and tap like that, we end up with this graph, and the graph there shows exactly what was the power usage inside the house today on a timeline. And it tells me I have used 3 1/2 kilowatts in my house today. Most of that came from the stove and the electric coffee pot. They're the real vampires, man. They suck. Yeah, I see at 4 o'clock in the morning there was a spike that was the defrosting mode in my refrigerator. There was another spike that came on, maybe right around 6:30. That was my coffee pot. And then we had yet a couple more spikes over there that were the stove as I was cooking. And the neat part of this is that they actually have a scale along the side here that tells you how many kilowatts that was when it peaks. And so I can tell what is the energy usage of almost everything in this house quite precisely. I'm becoming very familiar with how much stuff uses. Now here we see another graph, and this graph is showing me my battery storage. That's my Powerwall. And so you can see there that there wasn't much happening, and then right around 7 o'clock, 7:30 in the morning, we started to get juice coming in, and everything that's below the midline was going into the battery. Everything above the midline was going into the house. And there you can see the yellow is the solar collector. That's the energy coming from the roof that's been feeding the battery. And you see it's an even match, almost mirror-like. You can also see, if you look closely, that it has stopped. And there is the one issue that I do have, which is an incompatibility in reading what's happening between the app at Solar Edge and the app at the Tesla. When the car is charging, the Tesla is now disconnected from the collectors on the roof for reading them, and it has no idea where the juice is, how much the juice is. And so every time the car charger goes on to read what had happened, I have to go to the Solar Edge app. Now, Tesla and Solar Edge are not interested in setting their systems up so they can talk to each other. That probably isn't going to happen. I've been informed that. So it's a minor inconvenience to have to read two applications depending on what I'm doing around here. Down here we have performance, we have backup history. See, if I tap on this right here, that tells me every power outage that we've had and for how long they ran. I think that's pretty slick. So this gives me today's performance as far as how much is self-generated. And according to this, we are 49% solar at the moment and 51% Powerwall. So we are completely self-generated, contained within the house. On and on. As most apps, it gets quite detailed. There's a lot of stuff in here. And the way they do the graphics and the charts on Tesla, very easy to understand. I love reading this app. I really do. It's the Solar Edge one's good, and I do have to use it too because I'm using both pieces of equipment. But the Tesla app is extraordinary. That's the most remarkable piece of equipment. Yeah, so the Tesla, the Chevys are available here on the island. That was a major issue for me. I'm not to go about shipping something in. They were right here. I got a dealership. We got people give us help with any issues and so on. Plus, with the Chevy dealer here, they'll let us take this in and put it on their fast charge, which only takes about an hour and a half to run up a completely dead battery. They got a 440 charger. Mine is a 220. And so they have the level 1 charging systems over there, and they will do it for nothing because I bought the car there. And so when Ellen's going shopping over at Target or someplace, she'll drop the car off at Chevy, plug it in, get a free charge. When was the last time your gas station told you, I just stop in and fill up your car? So I'm happy with the Chevrolet. I think its performance is excellent. I will have to say that it is probably the best automobile I have ever owned. And I've had a lot of them over the years. An awful lot of them. I like this car. Yeah, I'm sold on it. Plus, if you buy an electric car soon, you're going to get a really cool plate here in Hawaii that says you got an electric vehicle. And look at that number, 026C. I don't think there's too many electric cars on the island yet, huh? Yeah, I like that. So you get a real low number. I can remember my license plate number. It's real easy. So aloha, folks. You have a great 2020. Thanks for watching The Green Garden Guy.